We will be doing a presentation today on max and min by Sarah
and Liz.
Okay, so the candidates for the extrema are endpoints, or the interval points, critical points, which can be broken into two parts. A, the first derivative of f when it equals 0, or the first derivative when it is undefined.
Okay, so how we would know if the point is a max or a min is first we would use the f derivative test for sign change, and we'll go more into that in the examples.
So the first example is f of x equals 1/3 x cubed minus 4x on the interval -1 through 4. So assuming that you guys already know how to take the derivative, we're going to just take the first derivative of this. It's going to be x squared minus 4 equals 0. And then we're going to factor that out so that it becomes this. Okay, seeing from this we can conclude that x equals positive or -2, and remember we have to include the endpoints as candidate points. So -1 and 4 are also possible candidates for max and min. Now taking the points that we found, we're going to plug it into the f of x equation that's originally given to us. Seeing from the interval that's given though, we can conclude that -2 is not in the given interval, so we don't even need to plug that in. So we'll skip right to f of -1. So when you take -1 into the original equation, it becomes 11/3. Next, our next candidate point is 2. So f of 2 equals -8/3. Our last point is going to be f of 4, which equals 16/3. Seeing from this, we can conclude that the max is 16/3 at x equals 4. Remember, y is, or max is, so y is, and x is going to be at. So at x equals 4. So remember, y is, and x is at.
Okay, so next we will show you how to find a max and min with the first derivative equation and using a sign chart. Yeah, so what we would do is we would have the derivative equal to 0, because it's already a derivative, and then we would simplify it out to this. Equals 0 to solve for the x, and then we can see that we have e's in each of them, so we can factor it out in e to the x. So it becomes x squared plus 2x minus 3 equals 0, and we can see that we can factor out this 2, so that becomes x plus 3 and x minus 1 equals 0, and then we can see that the x's are x equals -3 and 1. Okay, so from here we will be using the sign chart, and I'll go to the next page. So our points are -3 and 1, and for the sign chart, okay, it will look like this. We'll have the candidate points, -3 and 1. To find the max and the min, first we have to imagine the graph for each. So let me draw a graph here. The max will be looking like this, that is the graph, and we can see that this slope on the right side is positive, on the left side, sorry, and then on the left side we can see that the slope is negative. The minimum graph will be looking like this. We can see, and the slope on the left side is negative, and then the slope on the right side is positive. Sorry, it's kind of confusing. So what -3 and 1 represents are the max and min points, which would be right here, and right here, it would be right there because we can see that the slope at these points is 0, and that is why we have the first derivative equal to 0, as we see here. Okay, to find the slope of either side of the candidate points, we will have to use the first derivative, which we have right here, and we'll plug in numbers that are close to the candidate points. So on this side, we can use a number such as -4. So we plug in -4 into the first derivative, and that comes out to be 0.09157, which is a positive number, so we can just put the plus sign here to represent the positive number, which is a positive slope. Okay, and the next one, we can just find something between like 0, and if we plug that into the first derivative, it comes out as -3, so that is a negative slope. And then for here, we can use a number such as 2. If we plug it in, we get 36.94, which is a positive number. And then we know that the slope of the candidate points are 0. So we already established that the max was a plus and a negative, and we can see that we have a plus and negative at -3. So the max is at x equals 3. And then we said the min was a negative to a positive, which is at 1. So then the minimum is x equals 1. It's at x